let's just look at how to compare oxidizers and reducers. So if you look at some table, you have all these reduction potentials, and you see some negative values, you see some positive values. So you should be able to interpret that and compare different species. So oxidizers are oxidizing agents. Okay, that means they oxidize something else. Oxidizers take electrons. That means oxidizers are reduced. So we do want to look at reduction potentials. Reduction potentials that are positive are going to be like, this is something favorable. So keep that in mind anytime you look at these values. If you have positive values, that's something that tends to happen in nature, right? It's an oxidizer. So the best oxidizer that we have, or that exists, that well, it's on any standard tables. Maybe they've invented something exotic, but the champ is fluorine. So fluorine plus 2 electrons. You got a reduction potential of 2.889. You'll see this at the bottom of your table of reduction potentials. So that's just going to happen, right? And how do we find fluorine in nature, right? We find fluorine as F-. We don't find it as fluorine gas, right? They made this. You throw this on stuff catches on fire, right? Like this stuff, it's the most electronegative element, right? It's the only thing more electronegative than oxygen. So it is the best oxidizer. It's so good that we didn't really even know about this stuff for a long time. Anyway, so if we have less reactive metal ions, right? So if we have a metal that's not very reactive, think the noble metals. Think like copper and gold and silver, right? Less reactive metal ions tend to bring in electrons. So down here I have a list of some. I got iron, right? We deal with iron all the time. Things are made of steel, and so it's not all that reactive of a metal. It's kind of reactive, but iron 3 can be reduced to iron 2. That's got a positive potential. That's something that happens pretty readily. So don't stick your hand in that. We've got gold 3+ that can be reduced to gold 1.498. That's going to happen. So it's really hard to get gold ions. Then we've got down here, what's that right? I got nitrate. So less reactive metal ions, and don't forget about oxyanions, right? Oxyanions are oxidizers too. Anytime you pick up a bottle of this stuff at a storage room, their caps are yellow. Right? Yellow indicates it's an oxidizer. So, well, it's an oxidizer. It has a bunch of oxygen. So nitrate is an oxidizer. You see this value of 0.964. Note, oxidizers are things that become reduced. They take electrons from things. So we see electrons on the reactant side here, and the regular reduction potentials from a table you'd look at. So reducers, the best reducer of all is lithium. So if you look at the top of your reduction potential, you'll see lithium, but if we reverse that and we get the standard oxidation potential, we get 3.04. So if you combine fluorine gas and solid lithium, you will have the highest potential between two species that you can get, right? And it's something like close to 6. But 6 volts that would be the maximum for one cell, right? If you stack these cells, you can make a battery, and you can get higher voltages, like a 9-volt battery, right? Anyway, so active metals are reducers. So over here we have less reactive metal ions are oxidizers, but if you have an active metal with all its electrons on it, so it's not the metal, that's something that's going to tend to reduce something else. The reactive metal is going to give up its electrons. So you've got I got potassium here, right? 2.936. Lithium's the best, but potassium's not very far behind. Magnesium's a very reactive metal, 2.3. Aluminum, this is aluminum. We deal with it all the time. Aluminum does have some thin coating of aluminum oxide, but this is something that very readily gives up its electrons. So kudos to humanity for purifying